Okay, so we're going to pick up where we left off today. I'm not doing, if you're looking in your notes, the very last example, because it's more of a abstract example and I want to focus on more concrete just since we're short on time and the difficulty of it is already pretty high anyways. So there's a lot we're going to cover. I'm going to kind of do a little summary at the end for some key points for you to remember about projectile motion and how we attack these problems. So what we got to so far in class was we broke down the horizontal and vertical velocities. You're going to have to do that in most all cases in projectile motion, because depending on the question, sometime we need the vertical velocity, sometime we need the horizontal velocity. So let's start talking about A. What again we left off on was saying that we're going to have to find the time in two chunks. We're going to separate our picture into my top parabola. Now what you'll notice here about how we labeled this picture, this top section is an initial starting position of 30 to a final starting position of 30. This is also a position of 30 right there. So we're going to find that chunk first, and then we are going to find the rest of the time it takes to hit the water. So let's go ahead and start with that one first. The time it takes to return to 30 meters. So let's label our information. Our initial position is 30. It comes up, it comes back down to 30. That's what we're trying to do. We're trying to find the time it takes for us to return back to that starting position. And again, that means time is the question mark, right? We know that. Now we also know a couple other things. We know the acceleration. Once again, we have determined that the upward direction is positive. The diver went upwards first, so we're calling that a positive direction, and gravity pulls down. Since we are saying going up is positive, our gravity has to be negative here because it's pulling against the diver to start with. We don't care about what happens after that, but to start with, it is pulling against the diver, so it's negative. We also know one more thing. We know a velocity. Now, we have lots of velocities. We have a total velocity of 2, a vertical of 1.3, and a horizontal of 1.5. So for this question, to find the time it takes to come up and come back down, we are only going to be focusing on the vertical velocity because that is the one affected by gravity. Yes, your total velocity is affected by gravity, but only because it's the vertical component that is affected. So when we're doing this problem for trying to find how long it takes to go up and then back down, we are going to use the vertical velocity because that's the component being affected by gravity. So 1.3. Okay, so this is all I have. So because I'm looking for time and I have position, this is how we know we have to use the position formula. I can't use the velocity formula here because I've got position, right? We got position, we got to use the position formula. Sounds pretty obvious. Okay, let's go ahead and plug everything in. Okay, so I've got 30 over here equals 1/2 negative 10 t squared, we don't know what t is, plus 1.3, sorry, times, ooh, I gotta be careful here. No, that's correct, it should be correct. T plus 30. Again, let me double check something real quick here. Did I say I needed it to be negative? No, this is good. We're good. Don't listen to me. We're good right now because it's our initial velocity. Okay, so from here, go ahead. I'm going to put a little note on the Ed puzzle to just pause and solve it and then come back and check. Okay, let's see what we got. So you might have noticed something here because we've talked about this. We've got t squareds and we've got t's. Yeah? But what's going to happen also is when I move this over in order to do quadratic formula, I'm going to go ahead and simplify this. I got negative 5t squared plus 1.3t plus 0. Now, you can do quadratic formula like this using your c as 0. You can actually do that. So hopefully you did try that. However, here's what you can also do. If you have a c of 0, this is what I actually have. 0 equals negative 5t squared plus 1.3t, right? Again, you could have done quadratic formula and just said c is 0. Or we can factor out a t here. And I have factored this equation. If you guys recall, when you factor something, you take your two factors and set them equal to 0. And then you found your answers. So I'm going to show you that method. You should have gotten the same answer if you did quadratic formula, but used c is 0. So here's my two factors, t and negative 5t plus 1.3. Yeah? So I'm going to set them equal to 0. Hey, look, t equals 0. That makes sense because I have two positions on my parabola where my position is 30, right? I start over here at 30, I come back down to 30. So that makes sense. One of our times is 0 because that's where we start. The other one, we're going to go ahead and set equal to 0 and solve. I'm going to subtract 1.3 over. I got negative 5t equals negative 1.3. I'm going to divide by negative 5. And we are going to get that t equals 0.26. So what I have found is the time for the first chunk. I have found the time it takes to go starting at 30 and come back down to 30. Now we need the time it takes to go from 30 down to 0. So there's two more new positions. We're going to do the exact same thing we just did, actually. We just got to be mindful about our velocity because now it's going to be a little bit different. Okay, so let's try the second chunk now. So for my second chunk, once again, I have an initial position. What we said was the time it takes to start at 30 and come down to 0. To start at 30 and come down to 0. That's what we're trying to find. Once again, our acceleration is negative 10 because we decided that it's going to be negative 10. But here's the thing. You got to be super careful with this. I know my vertical velocity at this point. Because we've talked about this before, in a parabola, it's symmetrical. So if my vertical velocity at this point was 1.8, was that what it was? Sorry, 1.3. If my vertical velocity is 1.3 right here, it's also going to be 1.3 right here. It's symmetrical. But here's the difference. Right here, it's an upward 1.3. And right here, it's a downwards 1.3. So we need to change this to be a negative 1.3 coming down. Everything has to be consistent. And if you notice, this makes sense. My acceleration, I said, is negative, and it's pulling me down. And my vertical velocity at this point is also pointing downwards because the ball is dropping, or the diver, I keep thinking it's the ball. So my acceleration and my velocity are both headed in the same direction. They have to have the same sign if they're headed in the same direction. And t equals question mark. So from here, we do the exact same thing. We use the position formula. I'm going to go ahead and let you try this. Just like we did last time, you're going to need to use quadratic formula and see if you can solve for t. Go ahead and give it a shot. Okay, so going on from here, I got x final equals 1/2 at squared plus bit plus xi. Okay, let's check and see if you did this right. So So x final is 0. We're coming down to the water. My acceleration is -10. My t is, I don't know. My velocity is -1.3 because, again, I'm going to have the same magnitude of vertical velocity, but now I'm headed in a different direction. So we got to make it negative. T plus my initial position was 30. So this is a case where it's not going to, you have to do quadratic formula. You can't do it like I did up here where I factored out a t. Because we have this 30 on the end, we're going to have to do quadratic formula. So just real quickly, we got -5t squared minus 1.3t plus 30 equals 0. Okay, you should have gotten opposite of b. So 1.3 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, let's see what we got here. So I'm going to try the plus one first. 1.3 plus the square root of 1.3 squared minus 4 times -5 times 30 divided by -10. Okay, so I got a negative answer to start. So let's see if the other one doesn't give me a negative answer. So that's not going to be right. So now I'm going to try it again using the minus now. So 1.3 minus the square root of, we've got 1.3 squared minus 4 times -5 times 30, all divided by -10. Okay, so this gives me the positive answer. So 2.32. So don't need the negative one. So we are almost done. We have one more step. Think back for a second. What is our last step? I split my time up into chunks. What do you think is our last step? We need to add these times together. I found the time it takes in both cases, and I've got my parabola, and then I've got coming down to the water. So I'm going to add these two together, and this is my final answer. So 2.32 plus 0.26, I believe. Yep. This is going to be the total time it takes to come down to the water. It was a lot. The next part of this question is going to go a bit faster. Should get 2.58. So once more, we had to split it up into chunks. We weren't going to be able to do this one all in one chunk. Okay, so let's keep going. We're going to go up to B now. So B, how far does he travel horizontally before reaching the ocean? So here's what we know about the horizontal travel. The horizontal velocity is constant. Any motion in this direction is not affected by gravity, right? So what that means is this horizontal velocity is going to be the same throughout the entire travel. The vertical velocity will change because that's affected by gravity, but the horizontal velocity is not going to change. So they are traveling horizontally at 1.5 meters per second for 2.58 seconds. So this is going to be much easier. This goes back to a very easy formula we talked about in the very beginning, that your distance, or if you want to call this x, you can, equals your velocity times time. This is a very, very, very easy formula to work with because, again, we're looking at just the horizontal velocity. We're going this way for 2.58 seconds. So the distance traveled is going to be my horizontal velocity, which I think I remember being 1.5. Yes, horizontal velocity was 1.5, and we traveled horizontally for 2.58 seconds. So we've traveled 4.08 meters out horizontally. And that's it. Not very far out. Yeah, he's coming up and then coming back down. He's actually not going to come that far away from the cliff. That's how far he traveled horizontally before reaching the ocean. Okay, let's go ahead and try the next question. So this is going to go back to this question. It is, what is the velocity of the diver that we were just dealing with when he enters the water? So here's what we need. This is how you always have to attack these questions. What do we need to know in order to get what we want? Since it says the velocity of the diver, what this is talking about is the total velocity. Otherwise, they would say vertical or horizontal. With that in mind, to get the total velocity, we need to know the vertical when he enters the water, and we need to know the horizontal. And then we can do Pythagorean theorem to solve. So to start with, we know one of these already because it's constant, right? Which one of these velocities is constant? The vertical velocity. So we already know, horizontal velocity. Whatever. Horizontal velocity is going to be, I believe it was 1.5. I'll go back and double check. Horizontal velocity is not affected by gravity. So all the way throughout, our horizontal velocity is going to be the same. But our vertical velocity is going to change. Yeah? And let's see what it changes from. Now, again, we're going to kind of break this up into pieces, and there's an easy way to attack this. We know the velocity at this point. We also know how long it takes to get from that point to the water. We found both those things. So we're going to be able to deal with this like it's just free fall and find what the velocity would be after gravity has pulled it all the way down to the water. So we said the velocity at this point was just negative of what it was over here. And that happened to be a vertical velocity of 1.3. So again, at this point, that's a vertical velocity of negative 1.3, just the opposite direction. So looking at my picture, again, here's the cliff. Here at this point is where my vertical velocity is negative 1.3. I want to know the vertical velocity at this point. So I'm going to tack on something here. This is my initial vertical velocity, and this is my final vertical velocity. So let's lay out what we know. Once again, we have these two things. We have that our initial vertical velocity is negative 1.3. We're trying to find our final vertical velocity. We know our acceleration is negative 10 because it's pulling us downwards. And we know the time because we found that. We found how long it took to drop right here. So looking back to that problem, just the time from these 2 points, not the entire time, just the time from those 2 points, we found to be the 2.32. So looking at our variables here, go ahead and think through, what formula are we going to use? We're going to be using the velocity formula because that's all I've got. I've got velocity. That's what I'm working with. So my final vertical velocity is what I'm trying to find. Is my initial vertical velocity plus AT. So this is negative 1.3 plus a negative 10, so minus 10, times 2.32. So let's go ahead and do this math. We've got negative 1.3 times negative 10. Oh, sorry, minus 10. Whoop, that's my bad. 1.3, negative 1.3, minus 10 times 2.32. Okay, so we should have gotten that this is a negative 24.5. And again, that makes sense because originally we said up is positive and now the diver is traveling down. So that's why it's negative. So this is my new vertical velocity when he enters the water. Once more, we're looking for the total We now know he has a negative 24.5 vertical and a positive 5 going this way. Oh, for Pete's sake, I'm all over the place, guys. I'm sorry. It's not 5. That's from a different question. My husband is probably sitting in here laughing at me. The vertical is 1.5. Oh my goodness. The horizontal is 1.5. This is a mess. But I can't stop the video, so I have to keep talking. So from here, now that we know the vertical and the horizontal, we do Pythagorean theorem. And I will tell you something, guys. You'll see it in Pythagorean theorem anyways. Our total velocity is not going to have a sign. Yeah, it's going to be fine. Because what ends up happening here is we have negative 24.5 squared plus 1.5 squared. That's going to get rid of my negative. Equals my total velocity squared. So 24.5 times 24.5. So we got 600.25 plus 1.5 squared. 2.25 equals my total velocity squared. And again, we're going to take the square root of those after we add them together. Oh my gosh, why does this happen every time? Square root of 602.5 should get a total velocity of 24.5. Good Lord. Whew. So only a little bit different, actually. I know it rounds it off. That's because our horizontal velocity is really not that much. So it's not going to make the total that different from the vertical. That's just a coincidence. If our horizontal velocity was a lot greater, it would affect our total velocity a lot more. But in this case, it doesn't. Okay, so I'm going to have you guys try this one. I'm going to help you get it set up, and then this is the last one you are going to do. So the long jumper jumps at an initial speed of 10 meters per second at an angle of 45 degrees. What is the maximum height he reaches during his jump? So to start with, every single time, we're going to need to break this down into our X and Y components. Go ahead and try that based off what we did in class today. Okay, so let's see what we got. So our total speed is the 10 because they don't call it a vertical or horizontal. At an angle of 45 degrees. We need to know the horizontal and the verticals. So you should have done, just check your math. You should have gotten for the vertical, we should have done a sine of 45 equals my vertical over 10. Therefore, my vertical equals 10 sine 45. Therefore, 10 sine 45. You should have gotten 7. We'll go ahead and round that up to just 7. 7.07. And the same thing, we end up doing cosine 45 equals the horizontal velocity over 10. Just to differentiate this here. And so our horizontal is 10 cosine 45. Hopefully you're noticing a pattern. Yes, this happens this way almost every single time. And we get, hey, the same thing. That makes sense because this is a 45, 45, 90 triangle. If you guys recall, those two sides are the same in a 45, 45, 90 triangle. Okay, so what is the maximum height he reaches? We know things about maximum height. What we know is the vertical velocity at that point is what? It's 0. When we are looking at a maximum height, the vertical velocity is 0. So what we know is that our initial vertical velocity, that's VI right there, initial vertical, is 7. We just found that. We know that at the maximum height, my vertical velocity is 0. Because again, there's that little bit of hang time, right? And because this is free fall, we know our acceleration. Throughout all of this, guys, you should know acceleration is gravity. Now, because he's jumping up, gravity is pulling him down. Therefore, gravity has to be negative. Now, it just asks what is the maximum height he reaches during his jump. That's all it asks. What we have to do in order to get this, let me backtrack here, sorry. If we're trying to find the height, we are trying to find his final position at that point. And again, because he's just jumping up and coming back down, we're gonna go ahead and say that his initial position is 0. They didn't tell us, like in the cliff question, that we were starting at a certain height. Therefore, initial position is 0. So notice, I don't have time. Therefore, I'm going to use the timeless equation. Go ahead and give it a shot. Okay, let's come back and check this. So let's make sure you plug this in correctly. I know I have sort of new variables, but it's going to work the exact same way. My vertical final velocity squared equals my vertical initial velocity squared plus 2a times final position minus initial position. Okay, so hopefully you did this correctly. Let's plug it in. We got 0 squared equals, I got 7 squared plus 2 times negative 10 times x final minus 0. And we can leave that 0 off. So we've got 49 minus 20 times our final position. And we still got 0 over there. So we're going to move the 44 over. We got negative 44 equals negative 20 final position. Let's go ahead and divide. Let's see what this gives us. 44 divided by 20. This gives us a final position of 2.2 meters. So that is his max height. So because we didn't know the time it takes to get there, that's why we use the timeless equation. And we only focused on the vertical velocity because that is the component affected by gravity. Let me see, do I want to do one more? I think I'm going to go ahead and pause here, guys, for the video because I feel like I've already been talking for like 40 minutes. It's very possible. And then tomorrow, we're going to be reviewing for our test and doing more of these practice problems together. So I wanted to kind of give you an overview. There's one more thing I want you to write down. If you guys can go ahead and copy these into your notes, wherever you got space. Couple key notes here when we're dealing with projectile motion. We just mentioned this, but if we are dealing with max height, your velocity vertical is what I should have said there, will be what? At that point, what is your vertical velocity? It's 0. That's an important thing to note. And it is your final velocity we're talking about, but most importantly, we're referencing the vertical. Now, if we are asked to find how far we're traveling, so if I'm coming up and then coming back down, what we need to do, wow, I need to fix this. We need to find the time of travel and then we can multiply that with the horizontal velocity. Because again, your horizontal velocity doesn't change. So if we know how long it takes to go up and come back down, well, that's going to give us our distance after we multiply it with our horizontal velocity. Lastly, this is something we'll work on tomorrow, but if we're going to be asked to find the velocity at a certain point, so if I want to say, what's the velocity at this many seconds? Yeah? We need to find the components. Find the vertical and horizontal components. And then use Pythagorean, Pythagorean theorem to find the total velocity. So I know this was a lot, guys. Again, we're going to practice this the entire class period tomorrow. We'll review, and then we are going to have our test on Friday.